Hello, DevOps. It's so nice to be back here again. This is Murat. Obviously, I work in Google. This will be interesting because when I submitted this talk, I was working in the partner engineering team for Google Home. So the topic made sense. And a few weeks ago, I changed teams, so now I work in the Android team as a developer advocate, which makes things a little interesting with this talk now. So this talk, the motivation behind this talk is, I'm definitely not a hardware person, but if any of you can do something with Raspberry Pi, Android things, or any hardware, or know someone who can do stuff, basically I'll show you how you can connect your custom hardware, how you can create your own device and connect it to Google Assistant. So, Google Home is like my favorite gift. Every Black Friday or Christmas time when it goes on sale, I purchase a bunch of them and start gifting it away. And I love to watch friends and see how they play with it. Usually people start with asking the time, the traffic, the weather, set alarms. But the really interesting thing actually starts with when you start integrating your smart devices and your smart home with Google Home. And without that, you may run out of things to try easily. So let's talk about the smart home idea first. So basically, we want you to be able to control all your smart devices and get as lazy as you want. Basically, I don't want to look for my phone to just turn on the lights or start a movie stream or just check my front yard camera. You may argue I might be using a remote or a hardware switch to turn on the lights or do similar stuff. But come on, here I'm in Belgium, miles away from my home, but I can still check if my door is locked, get notified if someone is walking in front of my house. I can even turn on the TV and scare them. So it's a lot of fun. And we're all geeks, right? So basically, as I mentioned, we want you to be able to control all your different devices. And we are trying to put Assistant on as much as surfaces you might be interacting with. So let's take a quick look in Smart Home. We are all familiar with speakers, I guess, Google Home Mini, Google Home, and Google Home Max. And I'm pretty sure most of you already have Google Assistant on your phone. And early this year, our partners started launching smart displays, which is way cooler because you can see things on the screen now. I think it was last month, we announced a bunch of new hardware devices, and one of them was something very interesting, which is called Google Home Hub. And we'll definitely be talking more about that too. And not to mention, we are already connected to a lot of smart devices, and many more are coming. So our vision is basically we want you to be able to control all your smart devices from any surface you might be interacting with. For this, the first step is understanding what the user actually means. It might be a bit challenging to understand phrases like cut the lights or pop the lights. And imagine if you say, I'm cold to your roommate, most likely they will go and turn on the heater or the thermostat. So why wouldn't you expect the same thing from a digital assistant? You shouldn't be saying an exact phrase like, oh, turn on the thermostat, set the heat to some degrees. But it should be able to understand what your natural saying is. So if in past you built a Dialogflow app or heard about it, basically with a Dialogflow app, which is amazing, you define all the grammar yourself. And then you trigger your application by talking OK Google, talk to my app, which quickly starts your application. However, this might not be the best idea for a smart home app, because basically you don't want to talk to different brands. Imagine you're using 3 different light bulbs from 3 different brands. You don't want to talk them separately. You just want the lights on. You don't want to trigger each one individually. And another big issue is localization. Basically, you don't want to localize your app for each region every time we launch Google Home in a new region. So with smart home apps, users do not need to speak out the application name, but instead they should just say what they want to do. And we will figure out what the user really wants and send a request to your backend. This is done mostly thanks to Home Graph, which I will be talking about in detail. But simply, you need some basic stuff. Like, first of all, you need an OAuth2 provider for authentication. And you need to implement 3 simple intents: sync, query, and execute. So, wait, what's Home Graph? Let's take a look into that first. Home Graph is where we store your device data, your device capabilities, and know what rooms they are in. With that, we can understand what you actually mean when you try to do something. For example, in this slide, turn down the lights in the living room a little bit. This raises up some questions like, are there lights in the living room? Are the lights on? What are their current brightness level? And most importantly, what does a little bit actually mean? For a light, little bit might be a small percentage, but for a thermostat, it might be something huge. So basically, with Home Graph and the data we gather with the sync, we can understand what the user actually mean and transfer it into a really simple request to your backend. So the devices are stored, actually defined as types and traits in Home Graph. What's interesting is types don't come with default properties. If you say light bulb, it doesn't come with any default functionality, but traits basically define what a device is capable of. With the traits, you can easily define a vacuum cleaner with a light bulb. It doesn't make sense, but if you decide to build something like this, we'll be able to support it. So the only limit is you to build that device. So let's take a look at a few examples. In this one, we have a light, but without any trait, we don't assume this device can do something. Without any trait, we don't assume you can turn it on, turn it off, or change the brightness level, or basically do anything. So if your device can be turned on and off, we expect you to send us an on-off trait, which basically tells us this device can be turned on and off. Similarly, if you support brightness, we expect the brightness trait. And if the device supports color spectrum, we expect to see the color spectrum trait. Let's take a look at a different example, vacuum. We are developers, we are lazy people, so let's just copy-paste everything from the light bulb, which doesn't look exactly right. But if you build a device like this, yeah, we will be able to support it. But most likely, you don't want to start the vacuum. You don't want to turn on the vacuum. You want to start it. So instead of on-off trait, let's switch to start and stop, and put some more traits which will make sense for a vacuum instead of copying the light traits. We have all the available traits on the public website, so you can go ahead and check and see which traits are actually really fitting your device. So, where to start? First, you need a backend. It can be any backend which you can basically implement and handle the intents we will be sending you. Of course, you can use the Google Cloud Platform or choose any other provider you want. And here is a graph which shows what you need to have and what will be provided for you. So obviously, you need your hardware. And on top of that, you need an OAuth infrastructure, and you need to implement and handle the intents we'll be sending you. On top of it, we'll give you everything, natural language processing, localization, security, error handling, and etc. So let's talk about the intents which I've been talking about since I started to talk. So we have three intents: sync, query, and execute. Sync is where you tell us the devices the user has and their capabilities. Query is where we ask you the current state of a particular device or a list of devices. And execute is where we tell you to do a command on a device. Besides those, there is another important API called report state, which looks very similar to query, but instead of us calling you with report state, you call us to tell us the current device state. With that, we can execute most commands much faster, and with the visual display assistance, you can see the current state on screens. So before diving into intents, let's see how the flow works. So when the user gets your device, they go to Google Home app and select your application, which triggers the OAuth flow in the yellow part. The user completes the authentication, and immediately after the OAuth, we call sync, which will be asking you the list of devices and their capabilities. Once we receive the sync response, we store everything to home graph, and next time when the user asks for something, we basically first understand what the user is meaning, what they want to do by using the data in the home graph, and then send a query or execute to your backend. This depends on several things. For example, if the user asks to brighten the lights, first, we need to know what the current brightness level is. If you reported the last state to us, we can just send you an execute without querying the current device state. If you haven't implemented the report state, we first need to query your backend, get the current brightness level, then decide how much we need to increment the brightness, then send an execute to you. So let's take a look at the intent payloads. First, let's start with sync. As I mentioned, sync is called just after the user completes the account linking. So on the left side, you will see the request from us, and on the right, you will see your response. So sync payload is mostly empty. We send you a sync intent, and we expect to receive a list of devices and their traits. So this is where we get the initial device list and their capabilities and store it in the home graph. Next, query. Again, with query, we send you a query intent and also a list of devices which we are interested in. And we expect to get their current states in the response. Before going into execute, let's talk about report state, since the payloads for query and report state are almost identical with few differences. So as I mentioned, with query, we call you and expect you to send us the states. However, with report state, we expect you to proactively tell us when the device changes a state. This can be because of many different stuff. The user might be using your app instead of Google Home or another smart assistant or a hardware switch, such as turning off the lights from the switch. So any device change, we expect you to report it back to us so we can do things much faster. And since the way the API is called reversed, you need to use a JSON Web Token for authentication. And finally, our last intent execute is where the real action starts. Basically, this is where we ask you to change the device state. Similarly, we send you an execute request with an execution parameter. In this case, we ask you to set the brightness to 65, and we expect, hopefully, a success. Of course, things can go wrong, and if there's an error, you return us an error code, which will enable us to tell the user to give a nice feedback to the user about what's going on. Now, let's see some more detail on report state. So as I mentioned, report state basically lets you proactively tell us the state changes for the devices. This, as I mentioned, this speeds up the execution because for stateful requests, such as dimming, brightening, where we need to first get the current state, we don't need to do 2 round trips to your backend. Instead, we can use the local home graph data and decide on what to do. Second, we can show the current device states on smart displays. So I'm pretty sure it would be really nice to show your device on the display while the user is using the smart displays. So how do we implement report state? Basically, first we need to create a JSON Web Token, then use a JSON payload, which is very similar to query. First, let's say you need to go to the API console for your project and enable Home Graph API. Then create a service account key, which will immediately start a download of a JSON file. Then you need to form your JSON Web Token. If you're not familiar with JSON Web Tokens, don't worry, it's much easier than how it looks, and most libraries and frameworks mostly do it for you. First, you need to set your client email from the service account key. Then you need to set the API URL, current time, and current time plus 60 minutes. Then you need to sign the payload with the private key, which will give you a string in 3 pieces, which is the header, payload, and the verify signature part. If you want to validate your JSON Web Token, you can use the jwt.io and paste your token there, which will immediately show you if it's a valid or invalid JOT. So we have the JSON Web Token. Next, we need the agent user ID and send the post request. Agent user ID is much simpler because basically agent user ID is a unique field which you return us in the original sync response. Basically, agent user ID reflects the user ID on your side to us. So you need to go back and check your database or backend on what agent user ID you returned us in the sync response and use that to send us the report state request. Then let's talk about the JSON structure. As I mentioned, the report state JSON payload looks very similar to query. You need to list your devices with their changed states. If a state has not changed, you don't need to send it again. And finally, post that request to us. if you're interested in, you can do the report state by using gRPC and Protos. And it's also very simple if you're using Java. It just adds 3 Maven dependencies. If everything goes well, you will receive a 200 with an empty JSON payload. This means success, and you reported the state back to us. However, things might get wrong, and most common errors are 400 and 404. 400 basically means there's a syntactic problem with the JSON payload, and most likely it's a null instead of empty quotes, or you might be sending an integer value inside quotes, which makes us think it's a string value. And another common error is 404, which basically means most likely you are using a wrong agent user ID or a device ID, which we are not able to find it in home graph. This is tools in action track, so let's talk about some tools. First, we have a report state query tool, which I wrote myself with Angular and TypeScript. It's open sourced on GitHub. You can actually use this tool in any part of your integration and see what's going on in home graph, but it's especially very helpful if you're using report state, because you can easily verify if the state is reported back to us correctly. And the source file of this project contains everything with Protos and other APIs which you might be interested in. Another interesting tool is the simulator, which is super nice because you can basically type your commands on the console without speaking. This can be much useful than you might imagine if you're working in an office, because you can easily drive people mad by asking, turning lights on and off several times a day. So for development purposes, this really helps. And another helpful tool is Stackdriver. Basically, Stackdriver logs every errors you might be getting, and most of the errors during the integration happens during the account linking and OAuth stage, which is mostly not very visible errors, so Stackdriver can be very helpful if you opt it in. And we have a code lab on this URL. You might go and create your own virtual devices and interact with them. You can easily install the report state dashboard tool and see how you're interacting with the device and how it's reporting the state back. And with this, I'm happy to answer your questions. And it's really hard to see if any hands are up, so just shoot. Okay, thank you.